Hi there, I'm Spencer McLintock, and I'm here to talk to you today about the incredible, inedible seastar. A relative of sea urchins and sea cucumbers, this animal in the phylum Echinodermata, which means spiny skin, is very unique and amazing, and also very aptly named. In this artist's rendering, you can see that a seastar looks very much like a star, and exhibits what scientists call radial symmetry, where a central disk is surrounded by 5 arms, usually 5, sometimes more, sometimes less. And at the end of each arm, there's a little eye, which is not very highly developed. It can't tell images like you and I can, but it can tell the difference between light and dark. So this would be like if you close your eyes and look at and then away from a lamp, you should be able to tell, even with your eyes closed, when you're looking at the lamp. Now, also on the back, or dorsal side, are its gills, which aren't pictured here, and also little pincers called pedicellaria, which serve to cut up any algae or sediment that would fall or grow on the seastar and clog the gills. An amazing trait about the seastar is that if you were to cut off one of these arms, the seastar would actually grow that arm back. And if you cut off enough of the arm, from that arm would grow the rest of the seastar, resulting in 2 seastars. Also on the back of the seastar, you can see this little dot right here, which is slightly off-center and is called the madreporite. Now this is the opening to a very, very unique system called the water vascular system, and it's what allows the seastar to move. Instead of using muscles, the seastar uses differences in water pressure to contract and relax its tube feet, dragging itself along the ocean floor. And the madreporite is the opening to that, which regulates the water pressure inside the seastar. Now, on the other side of the seastar looks something like this. This is the ventral or bottom side, where each arm is lined with hundreds to thousands of these little suction-like appendages called tube feet. Now they're very cool because they can stick to rocks or to mussels, the seastar's main meal, which the seastar would eat using its mouth here. But if you've ever tried to eat a mussel, you know it's not easy to get the mussel out of the shell and into your stomach. So the seastar actually has a very interesting way to get around this. Instead of getting the mussel out of the shell, the seastar pushes its stomach out of its mouth and into the shell while gripping it with those tube feet to pry the shell open. In this manner, the seastar is able to digest the mussel outside of the body and then pull its stomach back in along with the digested material and absorb all those nutrients. Now, the seastar eating mussels is part of what makes it such an amazing creature, and also very ecologically important, because mussels are top competitors for space. If you've ever gone out to the tide pools and seen a mussel bed, you'll notice that they take up a lot of space. They're everywhere. Well, not quite everywhere, but that's only because of the seastar. If the seastar were not there to eat the mussels and free up space, the mussels literally would be everywhere, and there would be no room for other animals such as barnacles and anemones to settle. This would leave a really boring landscape where there would only be mussels around. Not the most exciting place. So it's a good thing we have the seastar around to eat those mussels and keep the biodiversity of our beaches alive and well. Now I'd like to talk to you about another very important aspect of seastars, and that's their reproduction. Now, as with most animals, there are both male and female seastars, but if you've ever tried to tell them apart, you may have found this very difficult to do. And that's because pretty much the only way to tell them apart is to actually see them spawn. Now, males will release a white cloud of sperm, whereas females will release a yellow cloud of eggs. And we can actually see these released because, unlike most animals, which use internal fertilization, seastars are what we call broadcast spawners. This means that they actually release their sperm and egg directly into the water column, where the sperm and egg will then meet, fertilize, and then float around in the water until the egg is ready to hatch and the young ready to settle down to the ocean floor. To do this successfully, seastars have to release their spawn at the same time. And they do this by getting certain cues from the tides or from the moon. Now, if seastars did this at separate times, then there would just be clouds of sperm floating around or clouds of eggs, and they would never have a chance to meet, and you would never get new sea stars. But because they're able to time it, they can actually successfully fertilize in the water column itself and start the next generation. I hope you've enjoyed listening to my talk on sea stars, and I hope you have a great day. Thank you.